All right, in today's lesson we are going to start proofs. So we are going to start out with algebra proofs first. So a lot of these properties you may have already learned last year when you took algebra. And these are properties of equality that we can use to justify our steps in solving an algebra problem. So to start out, the addition property of equality means if you have a quantity A that equals B, and these could be expressions, etc., then you can add the same value to both sides and you won't change the value. So then A plus C equals B plus C. So this allows you to add a quantity to both sides of the equation to solve. Subtraction property, A equals B. Then I can subtract the same quantity from both sides and still keep the value the same. So if A equals B, then A minus C equals B minus C. So you're subtracting the same amount from each side. The multiplication property says if A equals B, then A times C equals B times C. So again, we're multiplying both sides of the equation by the same quantity. The division property says if A equals B, then A divided by C equals B divided by C, as long as C does not equal 0, because division by 0 is undefined. The distributive property means we multiply through the parentheses. So if A times the quantity of B plus C, then A times the quantity of B plus C equals A times B plus A times C. So remember, you have to multiply whatever's in outside the parentheses by both quantities in the parentheses. Substitution property means we replace. Just like if a teacher is absent, you have a substitute teacher. So if I have A equals B, then A can be replaced by B in any expression or equation. The reflexive property, just like looking in a mirror, you see yourself. So for any real number A equals A. So a quantity equals itself. Symmetric property, if A equals B, then I can turn it around. Think of like converse. Then B equals A. So I can switch. Transitive property, if A equals B and B equals C, then A equals C. So these are all properties of equality that we use when we are justifying steps to an algebra equation. So now we can use these properties in a two-column proof. So a two-column proof is essentially, on the left-hand side, we'd be solving an equation like we normally do, but then on the right-hand side, we now have to justify or give an explanation for how did we do that? How did we know that we could go from step 1 to step 2? So on the left side, we list what's called statements or steps. And then on the right side, we list the reasons that justify each step. So what can you use as reasons? We can use properties like the ones we have above. We can use definitions. We can use postulates, which are accepted geometry facts or other math facts. And we can use theorems, things that have already been proven to be true. So let's look at a simple algebra proof. So in a proof, you always start with given information. You have to have a starting point. What you're trying to prove is always your ending point. So we always start with some piece of given information. So we'll start with 4x minus 1 equals 27. The reason it's given. And then we always make sure the last step of our proof is always going to be what we're trying to prove. So we're going to try to show that 4x minus 1 equals 27 will give you an answer of 7 for x. So to go from step 1 to step 2, how did we get from 4x minus 1 equals 27 to 4x equals 28? Well, if you solve the algebra problem, you know we added 1 to both sides. So if we add a quantity to both sides, if I back up to the top, that's the addition property. We added 1 to both sides of the equation. So for your reason, we use addition property. Then from step 2 to step 3, how did we go from 4x to x and from 28 to 7? Well, when you normally solve the algebra problem, you're dividing by 4. So that is the division property. So you'll notice we don't add in another step that shows the work. If you need to, you can kind of show the work on a separate sheet of paper, and then we just put the reasons for each step next to that particular finished step. So 28 divided by 4 equals 7, and we're done with our first proof. So we'll do 2 more proofs together, and then you will finish number 4 and number 5 on your own. So this algebra problem, a divided by negative 6 plus 2 equals 5. So we want to show that the answer will be negative 18. So start with what's given. Then we think, how did we get from 5 to 3, and from here the 2 is gone. So if we think about our algebra steps, we subtract 2 from each side. So to go from step 1 to step 2, subtraction property. Then we look at the next step. A divided by negative 6 equals 3. So to undo division, the inverse operation would be to multiply by negative 6. So if we multiply both sides by negative 6, these 6's will cancel. You'll be left with A. And 3 times negative 6 will be negative 18. So since we're multiplying, this is the multiplication property. So basically your reasons are simply justifying each step. What did you do to go from one step to the next? Problem number 3. Again, we start with what's given. 9 times the quantity of 2x minus 3 equals 63. So we want to show that the answer is negative 2. So again, we write out the given problem. And then we think, how did we go from negative 9 times the quantity 2x minus 3 to negative 18x plus 27? Since there are parentheses here, and we had to distribute the negative 9, this is distributive property. Then take a look at step 2 to step 3. So we had 27 on the left and 63 on the right, and in step 3 we have no 27, and this is now down to 36. So again, we must have subtracted 27, so subtraction property. And then here, negative 18x equals 36. So since this is a multiplication problem, you divide by negative 18 to solve. So 36 divided by negative 18 is negative 2, division property. and your proof is complete. So if you pause this video and work on number 4 and number 5, then we'll show the answers. So to go over the answers for number 4, again, always start with what's given. We subtracted 6x from both sides to get from 8x to 2x, so subtraction property. Then we added 17 to both sides, so addition property got us from step 2 to step 3. From step 3 to step 4, we needed to divide by 2, so division property. And then we want to prove that x equals 12. So when you finish a proof, you want it to look exactly like what was asked of you. So since this was 12 equals x, we want to rewrite that as x equals 12. And we're allowed to do that because that is the symmetric property, when we can just switch these. In problem number 5, again, we had parentheses on both sides this time. So we multiplied across the parentheses, distributive property. We did what you guys learned in algebra last year as combine like terms. So we combine negative 7x plus 4x gives negative 3x minus 14 equals 12x minus 24. So some people like to use the word simplify because we just simplified step 2 down to step 3. You can also use the CLT, which means combine like terms. So if you want to use CLT as a reason when you simplify, you can use that as well. And then from step 3 to step 4, we subtracted 12x from both sides, so subtraction property. From step 4 to step 5, we added 14 to both sides, so addition property. And to finish off the answer, we had to divide by negative 15, so we got positive 1.5 by division property.